All right, let's get drawing. So what you'll need for this is we're going to be looking at page 3 and 4, but you might want your own mini whiteboard, you might want your own iPad to do some drawing, or you might want just some paper beside you. So if you need to pause and get those things so that you can practice, that's not a problem. All right, so when we talk about organic compounds, there are a whole bunch of different organic compounds that we're going to be looking at. So in particular this year, we're going to be focusing on hydrocarbons, alkanes, alkenes, and another one called alkynes. Yeah. We're also going to be focusing on the alcohols and the carboxylic acids. We're not going to do too much on the halides, haloalkenes, and chloroalkenes at the moment, but we are going to be doing esters as well. Okay, so they're the 5, and these are some of the families that we've got here. So, reading from your notes, it says under families of organic compounds can be divided into many different families based on their differing structural features. Some families have double bonds, others have ring formations, and some contain extra kind of what we call functional groups, so little bits that tag off the side of them. Firstly, there are many families of hydrocarbons. So we're going to start over on this branch over here and talk about hydrocarbons. And in particular, we need to know alkanes, alkenes, and alkynes. But we're going to start on alkanes because they're nice and easy. So funnily enough, all of the compounds that are made out of alkanes, they all end in ANE. Okay? So this might be butane, methane, ethane, propane, pentane, hexane, heptane, octane, nonane, decane. Yeah, they all end in ANE. Now, what they are called is they're called a homologous series. So it means that they have homo meaning the same and logos meaning kind of progressional or next to each other. So we've got every time we add another carbon, we also add 2 hydrogens. So a general formula applies. And that general formula is where you add CH2 every time you go up another level. So what this means is we only have single bonds in an alkane, and these are what we call saturated. Now the reason they're saturated is because of those single bonds. So these two things are linked together here. Now this is the general formula for alkanes. CN, yeah, where N is any number, H2N plus 2. So that means that it's 2 times the number of carbon atoms plus 2, and that will be your hydrogen. So let's just have a little bit of practice with the first one here of methane. So methane, if our formula is CnH2n plus 2, the N is 1, yeah, which we don't have to write down. The H, and then we've got 2 times 1, which is 2, plus 2 is 4. So that makes sense. So this is what we call its semi-structural formula. So we are on the next page after the alkanes page, and it says we're going to complete this for the first 10 alkanes. So I'm going to work through a couple with you, and then I'm going to let you do the rest yourself, and then you can come in and you can show me what you've done. So this one here is the semi-structural formula. So at the top of that page, it says semi-structural formula, or the condensed formula. So it's a way to represent the molecule structure without having to draw out all of the bonds. So the atoms within the molecule are written the way that they are connected to each other. So it doesn't make too much sense now, but when we go into ethane, it will make more sense. So we know that every carbon, so remember our golden rule is that every carbon, each C atom bonds with 4 others. Okay, so it needs to have 4 lines. So let's just check when we draw the carbon. 1, 2, 3, 4 lines. Yay, we're all happy. Okay, so this one, the prefix for anything that has 1 carbon is meth. The prefix for anything that has 2 carbons is F. The prefix for anything that has 3 carbons is prop. And the prefix for anything that has 4 carbons is bute. We need to know all the way to 10. So it goes meth, F, prop, bute. Then we have the rest of them are a little bit easier. They're words that you might have heard before. So pent means 5, like pentagon. Hex means 6, like a hexagon. Hept means 7, like a heptagon. I'm just going to use all those gons. Yeah, so these are all the same. So from here, these ones are nice and easy to remember. The first 4 we have to remember on our own. Yeah, they're not going to go away, and they don't have that nice pattern like we're used to. So pent is 5, hex is 6, hept is 7, oct is 8, non is 9, and dec is 10. But the first ones are meth, eth, prop, and but. So what I'm going to do is I'm going to set you a challenge to come up with a mnemonic to help you remember that meth is 1, eth is 2, prop is 3, and but is 4. Okay, so that is what you're going to be doing. But let's go through our second example. So this should be written in your notes in the first box. The second example is ethane. So eth tells me that we have 2 carbons, and the ane to me means CnH2n plus 2. Okay, it's an alkane. So we fill in that formula and we end up with C2H, 2 times 2 is 4, plus 2 is 6. So that is our overall formula, is C2H6. And what I do when I draw it is I always draw like this. Okay, I always draw my carbons first. So I've got C2H6. I'm going to draw my carbons first. I know that I have all these single bonds, and I just go 1, 2, 3, 4, 5, 6. I must draw in all my hydrogens. And there we go. So what I've drawn here is ethane. Yeah. So what I would like you to do is I'd like you to fill in the rest of that table as best you can, or try propane, butane, pentane, hexane, heptane, octane, nonane, and decane. Don't leave them blank. Draw them in, because it really makes all the difference. And when you come into the meeting, I expect you to show me this, and we're going to do a little bit of a game so that you can prove to me that you know what we're doing. All right, the last little bit that we're going to do on alkanes is at the bottom of the top of the next page, and that's this thing called structural isomers. So with a formula like this one, this is butane. Okay, that means but means 4, and ane means that it follows the CnH2n plus 2 formula. So we end up with C4H10. But you can see here that it can be represented like one long chain, one shortish chain, called butane, or you can still represent it in the same way with this kind of little breakout here. It looks a bit like one of those Tetris blocks that goes like that. So that is called isobutane. Iso meaning that is an isomer, or another form of the same hydrocarbon. So reading this, it says the arrangement of the carbon atoms can be altered once you get 4 or more carbon atoms. And these are the isomers of butane. So the molecular formula is the same. They both have C4H10, C4H10. However, their shapes are different. This one goes up, or goes kind of all off a central carbon atom, and this one is kind of a long straight chain. These are called structural isomers. Now, VCAA requires you to be able to draw up to carbon 7. And that's what we're going to be doing when you come back into the class. We're going to be practicing drawing alkanes in general, and then we're going to be practicing drawing structural isomers. And that is the end of alkanes.